those days where if you didn't do your wrist exercises, you are going to wish that you had, because we're going to be writing down a whole bunch of mathematical postulates. Remember, these are things that will be acceptable arguments in proofs. Okay? When we start doing actual proofs, you can't just say, it looks that way, I think it's this, this could be it. You have to use actual mathematical definitions, postulates, or theorems. Okay? Postulates are, some of them have fancy names, some of them don't. The segment addition postulate is something that we learned back in CO2. The angle addition postulate is something that we learned in CO6. The ruler postulate is something we didn't talk about, but basically says you can use a ruler to measure stuff. I don't remember what the fourth one that we covered was, but anyway, these don't have fancy names, which is a bit unfortunate because, you know, if you were to ask me, hey Schultz, what's postulate 7? I don't know, right? I know what the relationship is if I read it, okay? But I don't have these memorized myself. Therefore, I don't expect you to memorize them either. They're key points. They can all go on a help sheet just like everything else, okay? But let's begin. Postulate 5 says that through any 2 points, there exists exactly one line. Through any 2 points, there exists exactly one line. I'll try and relate these to algebra where I can, because we've covered and worked with some of these postulates before. But when you think about when we graphed a line on a corner plane using y equals mx plus b, slope and so forth, how many points did we need? 2. Just 2. The y-intercept and the slope, right? Because through those 2 points, we could make a line. That's essentially what this is saying. Yeah.
What are the postulate 1 through 4?
Nicholas,
1 through 4.
pay attention.
He already said it, right?
We've already covered them.
What?
Some have fancy names like segment addition postulate, ruler postulate. But
I know, but
we've
which
already
number
covered
are those? Like, which one is one?
segment addition postulate, I think, is number 2. Ruler postulate, number 1. Yes.
3 and 4.
Repeat, please. Why can't this one be called the line postulate?
I don't know.
Couldn't there be postulates like 4 and a half?
No.
Is there 12?
Postulate 6. Postulate 6 and postulate 5 are kind of like cousins. A line contains at least 2 points. So postulate 5 says you need 2 points to make a line. Postulate 6 says a line has at least 2 points. They are kind of converses of each other, okay? But they are different postulates. Yeah.
Why are they shoes?
What?
So they're Converse.
Okay, very good. Hold on, I want to see. Wait, this
Avengers.
deserves
Avengers.
a.
Which one's the Avengers one?
Colin.
Why are you excluding the segments and rays?
These are what the postulates are. These are not my verbiage. These are the official geometric postulates for them. I don't know the reason for that, but we're just going with mine. Okay, Kristen? Postulate 7, the one I didn't know before. Oh, now I do. If 2 lines intersect, their intersection is exactly 1 point.
I could have kept that.
Yes, you could have. If 2 lines intersect, then their intersection is exactly 1 point. Basically saying that lines and rays and segments, all those things, can't intersect twice. Okay? If lines intersect, it happens at 1 point and 1 point only. And the point of intersection is simply that, a point of intersection. Yes?
By lines, does it mean like segment rays?
Are you Are you just trolling me now?
I asked the same question. What?
Are you just trolling me now?
No.
Yes.
We're so
It also refers to segments and rays and lines.
Then why
However,
did you say those?
This is the official verbiage of the postulate, and so I am going to keep the official verbiage of the postulate. Nathan, would you like to go show your parents your mouth talent? Then stop making that sound.
I was making one sound.
Sam, Mason, Paul, are we good? Colin.
So like, when you say lines, does that also mean segments and rays?
Okay, we're done. Postulate 8. Through any three non-collinear points, there exists exactly one plane.
What?
Through any three non-collinear points, there exists exactly one plane. Remember, a plane is essentially an area of space that contains those three non-collinear points. Because with 2 points, right, I can make a line, no matter where those 2 points are. But if I add a third that's not collinear, now they're contained within this plane. Okay, here, I'll get that out of your way for you. So through any three non-collinear points, there exists exactly one plane. Yes, Bria.
What are we gonna use this for?
Proofs.
Okay,
What are we
gonna
using proofs for?
Proofs are the basic of all logic. It's the basic of all problem solving. Proofs carry over into basically every career path, because every career you've got problem solving.
So this is
What
important.
about postulates?
This is important.
What about postulates?
Postulates are the definitions that you use to create arguments. Not all of you will be doing mathematical proofs, right? But you problem solve every single day. Some of you are good at it, some of you are not so good at it. Okay? Very similar. Oh boy. Leah!
Unit.
Our last one is 16.
What do we start at?
Sam.
I know you kind
We
of
started
said it,
at
but what's like the definition of a postulate?
A postulate is essentially a mathematical property. It's a mathematical truth. It's a, yeah, we'll go with that. A mathematical truth. That's probably the best way I can call it. Briggs.
Why do we need logic?
That's a very
What are
simple
postulates
question.
1 through 4?
That's
That's
a
a
very
very
logical
logical question.
Briggs. Have you ever been to the corn maze across the highway there? Okay. Because I have, right? And on the busiest of days, I will tell you, without a mapped out plan and people to help guide cars and folks out of that parking lot, it would be quite the show.
Is that
Would you agree?
Is
What
that
if
directed
people
at
just have common sense?
Is that directed at
Right. Even with common
Is that
sense,
because
then
Says is-
Nathan, if you could rely on people's common sense, then whoever owns that fantastic maze would not have to pay. Paul, out in the hall. Would not have to pay people to stand there and help guide cars, right? If we could rely only on people's common sense, then, well, we can't do that.
the world?
Okay. Garrison.
If this objective is important, why is it CO?
So PO 16, the proofs one, that's the PO. That's where you use all this stuff wrapped in that. Typically the POs, they use a lot of the COs in them. If I could make every CO a PO, I would,
There's only
right?
one
That's not
PO.
realistic. But PO 16, without all this other stuff, you're not going to pass it.
There's only one PO in this whole thing.
Nathan,
When does your plane take off?
Nick,
So is logic part of geometry or is it a whole nother thing?
logic is part of geometry, yeah.
Oh,
All right, caution number 9.
Andrea has a question.
Yes, Andrea, sorry.
What? Oh,
Justin.
so, does there always have to be a plane with 3 points? Like, can't they just be like 3 points like floating in the abyss?
Right, but if they cannot be connected with a line, then they're in the same plane. Okay?
Isn't it like super duper far away from each other?
Yes, even if they're super far away from each other. The exception to that would be if you had 2 points that were like You know, if I had like a point here, and I'm not even watching anymore, so never mind. Colin,
Show us.
put it back. Put it away.
Do planes go on indefinitely?
Yes.
So something that doesn't really make sense if you have multiple planes, because wouldn't it just be the same plane that just goes on forever?
Multiply. So if you think about like where I was going with what she was asking earlier, right? If I hold my hand out here, okay, I've got a point on my thumb and a point on my pinky, I can connect those with a line, right? If I have a point on my ring finger, which is not in the same line as these 2 points, they're connected in the plane. Okay. However, if I have a point here and a point here on the same horizontal plane and then a point above them, they would not be coplanar, because a plane is flat. It's like a sheet of paper. It's a 2-dimensional thing. Correct. Real.
If planes go on forever, how can you contain them in a box?
The points are contained in the plane.
That's a very big plane.
The line.
Nathan,
Why wouldn't you just connect all the points? Like,
you can, but not with the same line.
well, yeah, but like, then why would you roll it? Like,
So this is
some of these lines are making a
Can that
triangle.
plane fly?
Some of these lines are connected though.
Right.
I mean, you can connect another one.
Andrea, sit down.
Honestly, I need a chair.
Thank you.
Then it just makes sense.
3, 2, 1. You are quiet. Owen, that's enough of that. Naveen.
What is the 3D version of one? Is it just space? Is there like an
There is a plane is by definition a 2-dimensional thing.
like a 3-dimensional like
I mean, when you make a 3-dimensional figure, you are creating it with several planes that intersect to form volume, I suppose. But by definition, a plane is a 2-dimensional figure. Sam.
I thought a plane is something that flies.
Yeah. Nate probably made it.
Can that fly?
Eli.
What's like a 4-dimensional plane? Possible that one.
They say the 4th dimension's time. So wrestle with that one.
Are we all
Izzy!
in the 4th dimension?
How do you determine the size of a plane?
Sorry?
How do you determine the size of a plane?
I mean, you can't really measure a plane. A plane is the as big as you need it to be. You know, if your points are pretty close together, the plane would be relatively small, as I've drawn here. The more spread out that your points are, the bigger the plane's got to be. But again, by definition, planes are infinite. Briggs.
Do you think the 4th dimension exists?
Sure.
Because Mr. Rohr says it's science fiction.
Oh.
And Mr.
Andrea.
So yeah, with your hands and like the 2 dots here, wouldn't that your point on here be on the like there's like an X, Y, and that'd be on the Z?
You could label points Z, but they wouldn't be all in the same plane.
But wouldn't it be like on like just like
The Z-axis?
yeah, these Z
Yes.
axis.
Yes, but it's not a coordinate plane anymore then, right? It is
Can
more.
you have like a Z axis and like a Z axis without the Y?
A Z and X.
Well, it would just be a.
Y would be 0. Yeah. You have to have a point somewhere on Y. It'd be 0. Without it, yeah. Kill it!
According to Nate, you can't call it a plane unless it flies.
I never
Right,
said
yeah.
that.
Nathan made that joke, and then Sam made that
I
joke.
never said that.
Can I make that joke?
Technically, they worded it differently.
Cole!
I didn't hear Nate. You like
We're gonna go on?
No.
Postulate number 9!
Guys, leave me.
Explain!
Wait, what's 9? Guys, be quiet.
Yes.
Please, number 9 words.
A plane contains at least 3 non-collinear points. So just like how 6 is kind of the backwards, the converse, so to speak, of 5, 9 is kind of the backwards, the converse, so to speak, of 8. Through any 3 non-collinear points, there exists a plane, is what 8 says. 9 kind of switches around and said a plane contains at least 3 non-collinear points. You'll find that that geometry and doing proofs is very, very specific. it almost like annoyingly specific. And that's where most people fall apart with the proofs, is they're not being specific enough. So you might say, 5 and 6 say the same thing. Yeah, in a sense they do. 8 and 9 say the same thing. Yeah, in a sense they do. But they are two different statements. Paisley.
Can you explain postulate and the definition of it in a little bit simpler way?
Mathematical truth.
What's a truth?
It is
What's mathematical?
Mathematical rules.
a rule, sure.
Math rule.
Mathematical rule.
No, it's a math rule.
What
Why don't they just call it a rule, not a postulate?
Why don't they call it math?
Wait, why don't they? You did that to me last week.
Nathan.
So I'm trying to think for a minute. Come back to me.
Will do. Nick.
So why do they call it a postulate? Why don't they call it like a rule? It's a postulate.
Rule 9.
Because it's a math rule.
But it's
I do not know the origin of the word.
Ooh, I know why. Can I look it up? I know why.
All right, now.
I know why.
Do you know that?
Julian, turn around, please. Naveen. Tristan, stop talking to Julian. Thank you.
If a plane is infinite, then how big is the airplane? Can an airplane fit inside of it?
Nathan.
So I know why it's a postulate. It's because it's a math rule and you have to be very specific about things. Just like it's teaching us in this class, you have to be specific. That's why there's two things for the same thing.
Caitlin.
If a plane goes on forever, then how can there be multiple? If they just go on forever.
Because they have different directions.
But they collide
You
into
can have
each other.
a plane that sits like this, a plane that sits horizontally, a plane that sits vertically.
But still, though, then they just
Then shouldn't the answer for all of them just be infinite?
Izzy. Okay. Colin.
So if we're supposed to prove things with postulates, what do we prove postulates with?
So theorems are proved with postulates. Postulates are kind of like those obvious things that don't need proofs. They almost come from conjectures and definitions. Like when we defined a line before, we said that a line went on forever, it was straight, it contained at least 2 points, right? So postulates are kind of derived from definitions, and then we use those to make theorems. So as far as like where they come from, they're in the conjecture family, okay? But there are no counterexamples to them. So I would say that they are conjectures without discovered counterexamples. Might be another way to describe them. Anything else? Have you got your question filled? Nathan?
Can we switch 7 and 8?
No.
Why would we switch?
I want to erase this and scroll up if you're ready with. Yeah, Nick?
You think about that too?
No, I was never.
We have one on Thursday.
Why not?
So
We have 2 more
Folks. Caitlin,
is there a postulate 12 and so on?
again, a lot of them have other fancier names, so yes.
Why can't we see them?
Do you know what they are?
Not on my head, though.
How many do you know?
I know several if they have a fancy name. If they don't, then I really don't know what they are. Paisley,
Are there infinite postulates too? Infinite
I mean,
plane thing?
no, there's a set number. People are still discovering new relationships within geometry, so in a sense, they're infinite, and that every new relationship discovered is a new rule, a new postulate that can be used for something else. So yes and no. Currently, there are a finite number, but there's the potential for infinite.
And
Charlotte,
I think your tree looks a little bland.
thanks, Charlotte. Izzy,
So you didn't finish because he didn't list the S or the C in cent. Sorry.
the C. Cole,
What,
Talk slow.
basically, what's your favorite, like, what do you say it?
postulate.
Yeah, what's your favorite postulate?
I like them all.
No, like, you,
No,
like
you gotta
one.
be specific.
I can't.
One, like, 59,
Tell us to be specific and you
22, 81.
Caitlin, Nathan,
How many hearts do the octopus have?
are we all done?
Hearts?
Okay. Just so that we don't run out of time to do your homework, you need to look in your book for the other 3 postulates, so the ones we have not written. You can find those on page 96. You are to finish this page here by describing what you can conclude and cannot conclude based on the postulates that we talked about. And then from your textbook,
Page 96.
you are to do page 100.
I thought page 96 was in our textbook.
It is. Page 96 is where you can finish the postulates. They're all listed there. Page 100, 14 through 23.
Wait, what page?
100, 14 through 23. Then, in addition to that,
Addition.
Wait.
I would like you to do page 102, which is really an extension from 100, so this keeps on going on. You are to do 46 through 55.
I'm dropping out.
You wrote it wrong.
If you add more.
And then
If you are going to waste my time the way you did today, then I am happy to return the favor.
So you know what?
I didn't
one
big
Why are you giving it to the whole class?
Yeah, we deserve it.
Then on page 896,
I hate 96.
you are to do 1 through 11.
Oh my
What is
god.
that? What is
No,
this?
that's an easy one. What are you
that's-
talking about?
Wait, that's it?
What do you guys get?
And we'll call it
That's it?
quits there.
That's it. Keep going. Keep going.
So page 96, you've got the rest of the postulates. You've got this page to do here.
Let's get in the car.
Guys, it's like
On page 100, 14 through 23, 46 to 55, and then 1 through 11. Yellow.
You have to do this.
Yeah. I don't know. It didn't happen to me. I just happened to walk in there twice. And it looked like though it was. You know what? I can't even say. Okay. Bye bye.
Can I have a math packet?
Yeah. Good.
Charles, what's that red button right there?